Hello everyone, my name is Ernie. Today I'm gonna show you how to using remote sensing technique for water quality analysis. In this time I will show how to use or how to analyze NDTI, the Normalized Difference Turbidity Index, with using the remote sensing techniques. So what is NDTI? NDTI is a remote sensing technique used to estimate the turbidity of the water bodies, which is a measure of the amount of suspended particle like sediment, plankton, and pollutants in the water body. It is calculated using spectral reflectance data. So it's for calculated we need the spectral reflectance data from satellite. Particularly, the green and the red bands will be used for this index. And the range value is from -1 until to 1. Positive value indicating higher turbidity, and the negative values indicating the lower turbidity. So with this uh, index, we can mapping which area higher turbidity and which area lower turbidity using image from the satellite. So how to calculate it? The formula for NDTI is band number 3 minus band number 4 divided with band number 3 plus band number 4. So in this time, we will use band number 3 and band number 4 for calculate the NDTI or Normalized Difference Turbidity Index. And here I will use data from Sentinel-2. If you want to know about this data set, you can read in this description menu the detail about the data. And this is about the bands. So here we will use the green band and the red band, band number 4 and band number 3. For scaling, we will apply this value 0.001. So band number 4 and band number 3, the pixel size or the spatial resolution is 10 meters. Okay, and the revisit interval is 5 days. So every 5 days, we will get the data. If you don't know how to use or how to write the code, you can use this code. But if you know, just click this snippet and write your code here. First step, I will import my area or ROI. Here I will use the my area. Here, Kendari Bay, one of the bay in my country, Indonesia. So I will in, add the layer to the map ROI. So it will be showing here and make it as a center object. ROI with zoom 12. And and run it. So here my ROI. After that, just go to Sentinel-2, make a new variable here, for example Sentinel-2, and do the filter date. Which date do you need? Here for this data set, I will use for mapping my water body area. So I will use for cloud pixel is less than 1%. Filter bounds with my ROI, and I will use median value. So if you want to know how many data set do you have in this area for 1% cloudy, just run it. In the consoles menu, you will find, okay, I have only one picture here, only one. You can check it all. There is 26 bands and with 82 properties. You can check it if you want to know about the data. And okay, I will use the median, and after that, before because my ROI is look like this. If you go to the satellite, here there is land area included in my ROI. You can see it. Okay, here you can see. So I want to remove the this land area with uh, make a water body or mapping the which area with the water body. So I will remove the area without the water body. How to do that? Here, I will use another index. The name, the index name is NDWI or Normalized Difference Water Index. So that index, it will be showing which area for water body area. For NDWI, the formula is band number 3 minus band number 8. Band number 3 is green and band number 8 is NIR. So with this index, we will map the water index and run it. So here I have already one layer and for NDWI, but if you want to make it clear, just we will use the histogram chart. So just write the for make a threshold with area for ND or water. From the histogram we can see which area for the water. Okay, I have already print my histograms. Okay, run it again. Okay, here we will see that it's around 0 points. Yeah, this area is the water body value, so I will use the greater than 0.5 is the water body area. So here's I have already make a threshold is greater than 0.5. For example, here in your area you should find it by yourself this value. So after that, I add to the layers as a threshold, and for the hairs I will mask it with the threshold for the water body, and then run it again. So here there is threshold map, so the black area is already masking, so this area is indicate the land area. Okay, you can see it. So only the white area will be analyzed for the NDTI. After that, just do for your NDTI index. So here I will use the date is 2019 in July. Filter bounds with my ROI and the pixel value because it's not long range date, so I will use less than 20% and get the median value and multiply it with this scale. And for this I will masking with this threshold, so the NDTI will be calculate here with the formula band number 4 minus band number 3, or red minus green divided with red plus greens, and add to the layers. Okay, and then run it. Okay, for the visualizations you can go here, so it's not look nice. I will change it, make it straight 98%, and give the value, for example, the lower for value with blue colors. I will make it in 5, orange for example, and red value, and apply it. Okay, you can see. And if you want to make it permanent, just import it here, copy. Okay, change with this. Good. Okay, so now you have your NDTI, or Normalized Difference Turbidity Index, in your ROI. Okay, here you can see that's the higher value for your NDTI. Okay, that's for today. I hope you can learn something from this tutorial, and I will put the code in the description menu. Thank you very much.